Okay, so today we're going to, given a graph, write the function. Okay, so I see a line, a line, a line, a line. Let's remember, when we have a line, one of the easiest ways to write the equation for the line is slope-intercept form, y equals mx plus b. Now, this first line I see, and I chose to start here because we always go from left to right, from least to greatest values for our x. So we're going to start with this segment, and that is a horizontal line. The slope of a horizontal line is 0, so this is y equals 2, or f of x equals 2. Now, it's not continuous. It doesn't go forever left and forever right. So, now we have to write the constraint. It goes from an x value of right here to an x value right there, doesn't it? So it goes from -3 to 0. Now, we can include the -3 because it's a closed dot, and we cannot include the 0 because it's open. Now, some of you like interval notation best, but some of you like inequality. So if we wrote this as an inequality, we'd start off with a least value and write our compound inequality here. It goes from an x value of -3, but it includes the -3, all the way up to an x value of 0. But it does not include the 0. So you can write it that way, or you don't have to do both. You can choose interval or inequality. Now the second one is another line. It does have a slope. The slope is up 1/2, rise over run, 1/2. And we can clearly see the y-intercept is -2. Now this one starts at 0, and it goes forever right, which we describe as infinity. Or you could say x values that are greater than or equal to 0. One or the other. You don't need both. Okay? Now the next one. Let's take a look at this. This is up 2/1, up 2/1. It would go to right here. So even though it doesn't have a y-intercept because it's restricted, the y-intercept would be 3 if it was continued. So we would say this is 2x plus 3, and the way we show it doesn't get to go all the way there is it goes forever left, and then it stops right here at -1. Or you can say x values that are less than or equal to -1. Either way.
Would it have to be? Oh, never mind.
Okay. Now, I chose to let this solid closed circle go with my top equation. I could have said, this one is not equal to, but the next one is equal to. One is, the other isn't. And it doesn't matter which way you do it. You just can't do both. Okay? Now this one is just -x. And so since I chose to include this point here, I do not include it here. So I'd say from -1 to positive infinity, or x values that are greater than -1. So once again, it's interval or inequality, but you don't need both.
This is easier than I thought it would be.
Cool.
Like I got the sheet and I was like, oh.
Yeah, it was pretty.
Yeah, it looks a little bizarre, but it's not too terribly
So
difficult.
both of them can't have a closed circle?
Correct. We have to give it to one equation or the other.
So second.
Yep. So there are two right ways to do this problem. All right, you try. And if you're not sure what to do, you ask.
Alright, I'm going to start with the first one.
Do we do both of them or just one? Just one.
You know what? If you're
Yeah,
feeling like you got it, give it a try.
No.
It is.
We ready? Alright, we'll do that one in that color, that one in that color, that one in this color. Whoops, same color. Try again. Green. Alright, so we'll start on the left. This is y equals positive 1, and this is restricted over the interval from negative infinity to negative 3 inclusive. X is less than or equal to negative 3 if you write inequality notation. This one is up 2 over 3, so it's 2/3 x. The y-intercept is 1. This is over the interval from negative 3 all the way to positive 3.
Right.
Or you could write it as negative 3 is less than x is less than or equal to positive 3. And finally, the last one is down 2 over 3. So to go backwards and find where the y-intercept would be, we would go up 2 and left 3. So the y-intercept would be up there at positive 2. So that the slope is negative 2/3, and it would have been at positive 2. And this is from 3 to infinity, or you could say x values that are greater than 3.
It's 2 infinity?
Yes, because it's going right. So we're not talking about the y value, we're talking about the x value. Alright, we'll do the same thing with this one. We'll do this part. We'll do this part. And then we'll do this part.
So these are, I'm guessing,
Okay, so let's talk about what you think they are. What do you think the blue part
I
is?
mean,
It's a piece of
A parabola?
It's a piece of a parabola. It's a quadratic. Okay? And it's opening down. So it's negative. The vertex has been shifted left 2. So it's x plus 2. And up 1. The vertex was shifted left 2 and up 1 from the origin. Left 2, up 1, opens down. Now I get a choice here. Do I include this solid here with this piece?
Sure.
Or with the next piece? It does not matter. So if we did it with this piece, it would be from negative infinity to negative 2 inclusive, or x is less than or equal to negative 2. So because I chose to include it here, my next one I cannot include. So it would be negative 2 less than x less than 1. Alright, that's just a little horizontal line. So it's y equals 1. And the final one is what type of function?
Exponential? Or is it logarithm?
Quadratic. It's just y.
It's quadratic.
X squared.
It's not still a parabola because it's up to
Y equals x squared.
It's just turned.
It is turned.
X equals y squared.
X equals y squared.
A cube.
It's a square root.
It's
One of
a
the
square
square
root.
Oh no.
Yeah, I knew that.
It's a square root.
Oh.
And somebody said log. Let's see if I could turn this into a log.
I said that, but you can't.
Yeah, you can.
Up 1. Could it be base 2? 2 to 0 is 1. 2 to the first is 2. No.
I
Close.
I
I
knew
mean,
it couldn't
if you weren't given that point, if you were just given those two, you could write that as a log. Okay. So this would be the square root of x minus 1 plus 1. Because it went right 1 and up 1. And this goes from 1 to infinity. So since I chose not to include the one with the horizontal segment, I should include the one here. Okay. So the back is classwork/homework. And about 10 minutes before the bell, I'll pass back the test.
Am I gonna get my This is so long.
I have not made it, but I'll.
There is a lot.
All right, that's enough for today.
I need to make that.
Finish
I'm
up?
sorry about that.
Wait, so there's the homework.
You just gone.
Yeah, the back is homework.
Already finished?
May I have the worksheet from this morning's math team meeting?
I'm gonna need to collect those